see the starter 72 second question, that is invisible, which has a difficulty rating of 787. So the problem says Alice thinks Bob has very weak math skills. Alice gave Bob three numbers A, B, and C and challenged him to find any positive integer k strictly less than 100 such that none of the three numbers are divisible by k. Help Bob find one such integer k. Under the given constraints, a valid k will always exist. Let's see the input format. The first line of input will contain a single integer t denoting the number of test cases. The next line says the first and only line of each test case contains three space separated integers a, b, and c. So we know what our input format is. Like, it is as the same as the last question. So what this question says is we are given three variables a, b, and c. We are given these three values and we need to find an integer k such that a divided by k is the remainder is non-zero value, non-zero remainder. Same goes with b divided by k is a non-zero remainder, gives us a non-zero remainder. The question says it is not the divisor, that means it gives a remainder when it is divided by k. So you should know that, or you should make out that. And when c divided by k is a non-zero remainder, the same thing. And now we need to find a k. We are given a condition that our k is strictly less than 100, less than or equal to 100, and is a positive integer. That means it lies between 0 to 100. So now what should be my approach to find a k? Right, I want from these three conditions, that is this one, and this one. I am sure that one of the if condition would be like a ampersand k is not equal to 0. You can make out, right? This can be written in the arithmetic or algebraic form as this, and these two statements similarly can be written like these: b ampersand k is not equal to 0, c modulo k is not equal to 0. Right, I can write these three statements as this, and yeah, now, and I know that this my k lies between 0 to 100. Now one of the if statement that I can give is, the complete if statement is a modulo k is not equal to 0, and right, the our k should follow all these conditions, 1 2 3. Our k should follow all these conditions. That's why we will give and over here. That's why we would give and then b modulo k is not equal to 0, and c modulo k is not equal to 0. So this is our if statement. Right, what we did, we just read the question, understood the conditions that were given, and we made an if statement. Right, this was the condition that non-zero remainder, non-zero remainder, and non-zero remainder. And this equation could be very well written. This equation could be very well written as this in our programming format, and the same way I have done with the rest two equations also. And then we want to find out a k that satisfy all three conditions. That's why we are using and operator over here. And yeah, that was our if condition. And now we know that this is the if condition to check whether our k is eligible or not. Now we need to find out k, right? We need to increment the values of k and everything. We got the condition from which we can find out if our k is eligible or not. Now let's find out k, or how we are going to find out k is, we'll use a for loop before our if statement. Like we'll use a for loop over here for I, or for k, I'm really sorry, k is equals to 1, because our k starts from, I guess, yeah, our k starts from 2. Our ABC starts from 2, so our k also would start from 2. So we'll start our loop from 2, because 1 is divisible by every number, so we don't have to check 1. And 0, there is no need for checking 0. So we'll start our loop from 2. So we are starting our loop from 2. And what is the condition? What a condition we'll have to give? That it is less than 100. Our condition was there, right? That k should be strictly less than or equal to 100. So we'll write that k is less than or equal to 100, and next k plus plus, and that's it. That's what we have to do. And like, it is not given that we need to find the minimum number or not, so there's no need for us to go for the perfect algorithm for this, because we need to solve the question, right? So it is the simplest way you can solve this question. And then I'll write that in the if statement, if this happens, then print our I, right? We'll print our I or k in that matter over here. C out our k, and then end l. I'm doing this code in C++, so that's it. So this is a if statement, and then we'll write a break statement, because we don't need to, or we don't want to engage our CPU more after getting an answer. So we'll write a break statement, which would allow us to come out of the for loop. So this was the whole code, and we are given that under the given constraints, a valid k will always exist. So we don't have to give an else statement to this question. So that's it. That's how the code is. And you can see over here, I have written the same thing. I have not written this exact same thing, but the logic matches. So yeah, you can see this, and this is how the code is done, and this is how we can solve this question.